In this video, we will learn how to find the Laplace transform for discontinuously piecewise defined function systematically. In order to do that, we need to define a function we call step function, u c of t. Okay. This function defined as this. UCT equal to 0 if t is less than c, and equal to 1 if t greater or equal to c. Okay, the graph of this function is like this. Here's a t. Say c is here. Use of t is less than c equal to 0 here, equal to 0. And bigger than c equal to 1. That's what they call the step function. Okay, we need to learn something else. Say, how about 1 minus uc of t? So this function, the graph of that, okay, this one is like this. 1 t is less than c, uct equal to 0, so 1 minus that equal to 1. And 1t is bigger than equal to c, and uct equal to 1, then 1 minus 1 equal to 0. So the graph of this function is like this. See here, they give you 1 here, then they give you 0 for the rest of things. Okay, one more function we need to, for example, like a ua of t minus ub of t. Okay. What this function looks like. Here's a t. This is u. Okay. Say a is here, b is here. Okay, for t is less than a, both functions are 0. Okay. So you have 0 minus 0 is 0. Okay, for t is bigger than a, the first one, uat is 1, and ubt is 0. 1 minus 0 equal to 1. Okay, like that. For t is bigger than b, both functions are 1. 1 minus 1 is 0. Okay, like that. Okay, if you know those three functions, we can write anything like step functions like this. For example, it's 2. For t is bigger than 0 and less than 4, and equal to 5. For t is bigger than 4, bigger equal to 4 and less than 7, and equal to minus 1. For t is bigger or equal to 7 and less than 9, and equal to 1. For t is greater or equal to 9. Okay, we want to find the Laplace transform of this. Okay, so using step function, we can easier to find the Laplace transform for. Our goal is to find this. Okay. So we don't want to like full expression for ft. We want to write one expression. Use our step function, use uct. Okay. So since our ft equal to 2, for t is bigger than 0 and less than 4, so you want to, corresponding to 2, you want some function like this. Here says 4. You want that equal to 1 and equal to 0 for the rest of it, so you don't interfere for the other things. Therefore, you can write like this. ft times 1 minus u4. Then plus 5. Okay, for the 5, you want, that's only, okay, only non-zero on the 4 and the 7. Okay. So you have like a 5 times u4 t minus u7t. Okay. This function give you 4 and 7, give you 1 there. Then 5 times that give you 5, and the rest of them 0. They don't interfere with the others. Okay. Then plus minus 1. This one you want to between 7 and 9, non-zero. So you have u7t minus u9t. Then the last one you want to, here's 9 here, you want to equal to 0 here. After 9 is 1. So you plus 1 times u9t. Okay. Then you simplify this, you will get 2 minus 2 u4t plus 5 u4t minus 5 u7t minus u7t plus u9t plus u9t. So you simplify this, you got 2 plus 3 u4t minus 6 u7t and plus 2 u9t. Okay. So goal of this, we write piecewisely defined function ft as one expression. Okay. So if we know how to find Laplace transform of step function, then we can find the Laplace transform of ft easily. Okay. So next, let's see how to find the Laplace transform. How to find the Laplace transform for step function. Okay, now let's find uct. This one by definition, 0 to infinity, e to the negative st uct dt. Uct is piecewisely defined. Sometimes equal to 0, sometimes equal to 1, depends on your interval. So between u and c, that's why we need to break our integral to 2 integrals. E to the negative st. For t between 0 and c, your uct equal to 0 dx, then plus c to infinity, e to the negative st. This time uct equal to 1, okay, dt. So the first one is 0. Okay. The second one, we just integrate that, give you negative 1 over s, e to the negative st, evaluate c and infinity. Okay. S is positive, then let t go to infinity, this one go to 0. So you got 0 minus negative that give you 1 positive 1 over s, e to the negative cs. Okay, so we know how to find step function Laplace transform. So we can find the Laplace transform of ft in the previous slides. Okay, easily. Okay, next we need to learn an important formula. It's like this. We want to learn what is the Laplace transform of uct times f t minus c. Okay, by definition, this one is 0 to infinity. E to the negative st uct, then f t minus c dt. Okay, again, we break this interval to the 2. One is 0 to c, one is c to infinity. 0 to c, uct equal to 0, so that one is 0. Okay, so we have this. E to the negative st ft minus c dt. Okay, now we want to do the variable change for this one. We let x here equal to t minus c, then dx equal to dt. So you got a negative st, t equal to x plus c. Right, you solve from here, t equal to x plus c. Then ft here, ft minus c, which we'll call the x, and the dt equal to dx. Okay. Now let's look at this. So when t is infinity, then x is infinity. Okay. When t is equal to c here, t equal to c, there x equal to 0. Okay. So this one can be simplified like this. 0 to infinity, e to the negative sx times e to the negative sc fx dx. So e to the negative sc is a constant. You can put that out. So you got negative sx, then fx dx. This same, okay, x here is a dummy variable. You can use either x or t. Doesn't matter. They give you same thing. So they give you e to the negative cs with c same thing. Then that's exactly Laplace transform of ft. Okay, we'll always use capital Fs. Okay, in this class, capital Fs is always, remember this, we'll always use this notation. Okay, so finally we got this important formula. UCT f t minus c, this is equal to e to the negative cs capital Fs. And this, whenever we got a formula, we'll always get a 2. This means inverse Laplace transform of e to the negative cs capital Fs is equal to UCT f t minus c. Okay, this formula is important. Okay, so what this formula means? This formula means if you're looking for inverse Laplace transform for this whole thing, what do you need to do? Just find inverse Laplace transform for capital Fs, which is small ft, then shift it. Alright, now let's look at an example. We want to find the Laplace transform for this function. Ft here is equal to sine t. If t is bigger than 0 and less than pi over 4, and equal to sine t plus cosine t minus pi over 4 for t is bigger than pi over 4. So this function has 2 pieces. So first of all, we want to find this Laplace transform of it. So first things we need to do, write a step function. So this one equal to sine t when t is bigger than 0, less than pi over 4. Remember, so you want something like this. Pi over 4 here, you want that equal to 1 here and equal to 0 there. Okay. So ft here can be write sine t times something. That means give you 1 for t is between 0 and pi over 4. That's what this function is. Then you have this sense, sine t plus cosine t minus power 4. You want this sense. Okay, you want to time something. That sense is equal to 1 for t is bigger than power 4 and equal to 0. Okay, for t is less than power 4. So that's exactly what this sense is. Alright, you simplify this. You got sine t plus cosine t minus power 4 u power 4 t. Okay, now we can look for its Laplace transform, okay, by using the formula. Okay. So Laplace transform of that is Laplace transform of sine t plus Laplace transform of u power 4 t times cosine t minus power 4. So that's exactly this formula with ft equal to cosine t and c equal to power 4. Okay, therefore let's find the first one, which is 1 over, you look at the formula, okay, you find this. The second one, we use this formula, okay. So, first thing is this formula is equal to this. So you just write like this. Plus e to the negative, you see here the power 4 s. Then capital Fs. Capital Fs, okay. Capital Fs is inverse Laplace transform of small ft. Your ft here is cosine t. Your ft minus power 4 is cosine t minus power 4. Okay. So the inverse Laplace transform, the Laplace transform of small ft is cosine here. This one is cosine t, which is s1 plus s squared. Okay, so to use this formula, to find inverse, to find the Laplace transform for this whole thing, you just need to find the Laplace transform of small ft, okay, which is a capital Fs. For this case, small ft is cosine t. Okay, so its Laplace transform is s over 1 plus s squared. So we're done. Okay, next example. Okay, so for this example, we'll also need to use this important formula. Okay, we're going to use this formula. I just copy that here. E to the negative cs capital Fs is equal to u c t f t minus c. Okay, again, Laplace transform of ft here is a capital Fs. Alright, now let's look at this example. This example, we're given the capital Fs, which is a 1 minus e to the negative 2s over s squared. We want to find the inverse Laplace transform of it. Okay, so inverse Laplace transform of capital Fs. Use the property. So this is like an inverse Laplace transform of 1 over s squared minus e to the negative 2s and 1 over s squared. Use the property of inverse Laplace transform. You just find each one. E to the negative 2s 1 over s squared. The first one is easy. Okay, now let's look at the second one. So for the second one, 2s 1 over s squared. So now let's use this formula. What does this formula say? So in order to find this inverse Laplace transform for this whole thing, what you really need to do, just find the Laplace transform for this things. This is our capital Fs here, which we know that. This one you can look at the table, give you 1 over t. This is our small ft. Okay, so by using that formula, to find this whole thing, you just need to find for this one, okay? Then use this formula. So give you UC. C here is 2. U2t. Then small ft minus c. Okay. As I said, small ft here, small ft Laplace transform give you capital Fs. So our small ft here is this. Therefore, okay, ft here is 1 over t. So what is ft minus 2 here? C equal to 2. So it's whenever you see t there, replaced by t minus 2. That's it. Okay. Wait, sorry. This one equal to t, okay? So Laplace transform of 1 over s squared equal to t. Okay. So ft equal to t. To get this one, you just look at that table, okay? Use that formula. So ft equal to t, then ft minus 2 just equal to t minus 2. Okay. So here you got like t minus 2. So the second term is u2t times t minus 2. Okay, so we can find this Laplace transform of capital for this whole thing. Okay. Laplace transform for this, well, what we're looking for is this. 1 minus e to the negative 2s over s squared is equal to this one, which is t minus u2t times t minus 2. Then we're done. Okay, we have one more formula we need to learn. This formula is like this. Laplace transform of e ct ft. We want to find this. 0 to infinity. E to the negative st times e ct ft dt. And this one is 0 to infinity. E to the negative s minus c t ft. Okay, remember Laplace transform of this ft is 0 to infinity e to the negative st ft dt. We call this capital Fs. Whatever you have there, you have here. So for this case, what we have s position, we have this s minus c. So this is f s minus c. Okay, so we learn formula like this. ECTFT is equal to capital F S minus C Okay, what that means? That means if you, again, always like this. So if you know the Laplace transform of small ft is a capital Fs, so if you're looking for this whole thing, you just need shift f there, replace s by s minus c. Okay. So this formula, every time we learn formula, we'll learn another one. Okay. Another one is like this. Inverse capital Fs minus c give you ECT ft. Okay, now let's look at an example. Okay, we're going to use this formula. Capital F S minus C is equal to ECT ft. Remember, capital Fs is Laplace transform of small ft. Alright, now let's look at an example using this formula. Our GS here is equal to 1 over s squared minus 4s plus 5. What do we want to do? We want to find inverse Laplace transform of GS. Okay, first of all, G of s can be written as s squared plus 4s and minus 4s plus 4 plus 1, right? We didn't change anything. This one can be written s minus 2 squared plus 1. Okay. So we give a name for that. We call this one is a capital F s minus 2. If this one is a capital Fs minus 2, then what is a capital Fs? Easily is s squared plus 1. Okay. So for the inverse Laplace transform of capital Fs, we know what it is, right? Which inverse of this one, 1 over s squared plus 1. By using the formula, this will give you sine t. However, that's not what we're looking for. What we're looking for is the inverse. Okay, we see that, right? G of s equal to this. So inverse of G of s, just inverse capital F s minus 2. Okay. And we know that we use this formula. They give you e to the c. C here is a 2. E to the 2t ft. Okay. Ft here, see? Look at it again. Okay. This one means inverse Laplace transform of Fs here is ft. Okay. So my ft here is sine t. So we're done. Okay. Okay. This is a little bit confusing. You need to work hard for it. Do many practice. Okay. Again, what does this formula means? To find the inverse Laplace transform of that, what do you need to do? Okay. To find the inverse Laplace transform of Fs minus c, what do you need to do? Just find its inverse Laplace transform of Fs. That's just easier. This give you ft. Okay. So then this one just give you e to the CTFT. That's it. Okay. Alright, in this section we learn several formulas. They're all important for you to find the Laplace transform easily, and so is the inverse.